Welcome back. Now it's time to dive into another of DAX's powerful time intelligence functions, DATEADD. Whereas dates year to date and its cousins were great for viewing accumulated to-date totals for measures, DATEADD's superpower is comparing measures and calculations across different time frames, month over month, year over year, etc. Like dates year to date, DATEADD also manipulates the filter context within a calculate function. The difference is, instead of expanding the filter context to the beginning of a year, quarter, or month, it instead adds or subtracts a specified number of date intervals to the filter context of the current cell in the pivot table. So take, for example, the row in this pivot table for July 2019. The revenue for that month is $314,000. Our year-to-date revenue for that month is about $1.9 million. That number, which is the output of the measure we created in the last video, is the result of using our revenue measure as a starting point, but then extending its filter context backwards from July 31st, 2019, all the way back to the beginning of 2019. Now, by contrast, if you look at the value in the third column for July 2019 in this pivot table, under our revenue previous year column, we see a completely different number. But if you look back exactly 1 year in our revenue column to July 2018, you'll see a matching number. So this third column, which is being generated by a DATEADD function, is the result of again taking that revenue measure and then changing its filter context in the pivot table. Except instead of extending the filter context backwards, we move it a specified number of intervals. In this case, we move it back 1 year. Although the DATEADD function is highly flexible, so we can move it backwards 6 months or forward 3 months. The bottom line is we're not extending the filter context, we're moving it, essentially offsetting it from the current position of that cell in the pivot table. So now that we know what DATEADD can do, let's see how we can use it to build out a view like this. So to start, I'll set up a simple pivot table with year and month on rows and revenue on values. And now our goal will be to use the DATEADD function to recreate that revenue previous year value we saw in the example pivot table. So to do that, we'll of course, as usual, create a new measure, and we'll assign it to our order details table and call it revenue previous year. And then to start, we'll, as usual, use our calculate function. And for the expression, we'll feed it our revenue measure. And now for the filter, instead of using a dates year to date or dates month to date function like in the last video, we'll use this DATEADD function. Now, as was the case for dates year to date, and as is usually the case with time intelligence functions, the first argument is just going to be the dates column from our calendar table. So we'll enter that. Now the second argument is the number of intervals, the number of time intervals that we want to walk forward or backward in the filter context of our pivot table. Now that's really just a fancy way of saying, if we want to compare the current month's revenue against the revenue from 6 months ago, 6 months in the past, on the same line of our pivot, we need to offset from the current location in the pivot table minus 6 months. So our number of intervals would be minus 6. Now in this case, we want to go 1 year back, so we could try minus 12 months, or we could do minus 1 years. Minus 1 years is a little more straightforward, so we'll opt for that. And now for the third argument, we'll enter the interval of time that we're offsetting forward or backward from the current location in the pivot table. So we're going back in time 1 year, and as a result, our interval will be just year. And as you can see, the word year is a special keyword that the DATEADD function recognizes. Similarly, if you wanted to go back 6 months, you would just enter -6 for the second argument and then the word month for the third argument. But what we've entered here should take care of what we're trying to accomplish. So I'll close out the parenthesis for our DATEADD function and then our calculate function. And then we'll format our measure as currency, check formula, and then click OK. And now let's add that measure to our pivot table. And just from a quick glance at the numbers, it looks like our measure works. Our August 2018 revenue number matches our August 2019 revenue previous year number. And it looks like our other numbers are lining up as well. Now, one cool application of being able to sit the output of a measure for two completely different time frames side by side in a pivot table is that we can create additional metrics that show how that measure changed from one time frame to the next. For example, a % increase or a % decrease. And if we wanted to do that here, it would be a relatively simple matter. We can go back to our measures and create a new measure, which we'll call year-over-year revenue delta. And then our formula will simply divide current revenue minus revenue from the previous year by revenue from the previous year. And then I'll add blank here as my alternate result argument, and then check my formula. And since this is going to be a percentage, I'll format the measure as a number, and then a %, and then we can click OK. And now, just scrolling through the values of our pivot table, we see that these percentages make sense. In August 2019, our revenue was a little over $400,000, which is about a 54% increase over the previous August's revenue of $264,000. This ability to compare metrics over different time frames side by side is extremely valuable and also represents an incredibly common ask in the world of business intelligence. This sort of view would take a lot of work to set up without the power of DAX time intelligence functions. But as we just saw with DAX, it's really just a matter of setting up a couple of simple formulas. Now, one last housekeeping item before we go. As with our dates year-to-date function, our DATEADD function is producing some rows in our pivot table, which, while technically valid, don't exactly make for a great user experience. So our data set only goes out through August of 2021. But obviously for September of 2021, there is such a thing as a previous year revenue value for that month, because we did have data for September of 2020. But of course this means that our year-over-year comparisons are going to always yield minus 100% because we're going from whatever revenue we had in the month in the previous year to 0. Now that's clearly a pretty confusing user experience, so what we need is to modify our revenue previous year measure to return a blank if our current month revenue is blank. So we'll go back into our measures, and then we'll edit our revenue previous year measure, and just like with dates year to date, we'll use the isBlank function. So we'll type if isBlank revenue blank, otherwise return the measure we've already created. Now let's check this formula to make sure it'll work, and then click OK, and then close out of this to see the results. And just like before, our little tweak with isBlank was enough to get rid of those rogue blank rows in our pivot table. Now, one thing I'd like to emphasize before we move on to our next time intelligence function is just how smart the DATEADD function is. So say we were dealing with a leap year here, for example, and we were trying to compare one February to a previous February in which one of those Februaries had 29 days because it was in a leap year. DATEADD is smart enough to recognize that these months have different numbers and still compare the entire total for each month. Likewise, if we were comparing entire years to each other, and one of those years being a leap year had 366 days, DATEADD would compare the entire total for both years. It's not going to get confused by the fact that the years have a slightly different number of days. The bottom line is that you can generally trust the DATEADD function to be smart enough to correctly handle time periods with different numbers of days in them, and still make accurate period-over-period comparisons between these time frames. Alright, up next we'll dig into yet another time intelligence function that makes something else that would have previously been thought impossible in a pivot table, rolling totals and moving averages, fairly straightforward. I'll see you then.